Hello students, myself Dattadre Zadav. I am from Angel College, Kara. During our last lecture, we were started our new chapter, Shapes and Relations. In previous video, we learned about how to represent a set. There are two types of representations of sets. First one is set builder method, second one is roster method. And also we have studied different types of sets. Today we are going to solve some examples from our exercise. So first example is describe the following sets. Describe the following sets in roster method or roster form. First question is describe the following sets in roster form. In roster form, that means in listing method. In listing method. First example is A is given here, set of all x such that x is letters of the word movement. Now look at here. The question is describe the following set in roster form. There are two types of representation of set. That is, one is set builder method, second one is roster method. Means here the set is given in set builder method. That is formula form. Set of all x such that x is letters of the word movement. Now I want to write this in roster form. So for that I can write here in solution given A is equal to set of all x such that x is letters of the word movement. In the word movement, the letters are M, O, V, E, M, E, N and T. Now I can write this in the form of list. So in a roster form, I write the set as A is equal to set of curly bracket. Yes, first letter is M, second letter is O, third letter is V, fourth letter is E, fifth letter is M. Since it is written here, so don't write. If any element of the set is repeated, then write only once. So fifth letter not right there. E is also written here. Next N, and lastly it's T. So here we list all these elements, yes, of the set A. And I am writing here cardinality of A. N of A is equal to what? How many elements are there? 1, 2, 3, 4, 5 and 6. So N of A is equal to 6. It's our first example to write the set in roster form. Now moving to our next example. Second example is B example is, it is a set. Describe the following set in roster form. Set of all x such that set of all x such that x belongs, x is an integer, x is an integer which is lies in between minus 3 by 2 less than, strictly less than x, strictly less than 9 by 2. X is B is a set of all x such that x is an integer. Integers means what? Integer means whole number, natural numbers with the negative sign. I am writing a set of integers as minus infinity to minus 3, minus 2, minus 1, 0, 1, 2, 3, so on. All natural numbers with their negative sign including 0. That set is called as set of integers. So x is a set of an integer such that what is the condition is here? Minus 3 by 2 less than x less than 9 by 2. Minus 3 by 2 less than x less than 9 by 2. It means that minus 3 by 2 is what? After simplification, I am writing minus 3 by 2 as minus 1.5 less than x less than 9 by 2 is nothing but 4.5. So I am writing here 4.5. That is all the integers between minus 1.5 to 4.5. Yes, in between minus 1.5. I am counting the numbers here, integers. Here is our minus 1.5, minus 0, 1, 2, 3, 4, 5. So here is minus infinity, here is plus infinity. Now, where is 4.5? Here is 4.5. Here is 4.5. And here is minus 1.5. And in between these two numbers, which integers are there? So in roster form, the set B can be written as. In roster form, the set B can be written as. Yes, minus 1. Here is minus 1. In between these two numbers, minus 1 is there, 0 is also there, 1 is also there, 2 is also there, 3 is also there, 4 is also there. 5 is not included in this interval. 5 is not included in this interval. So B is set such that B is equal to curly bracket minus 1, 0, 1, 2, 3, 4. Curly bracket completed. Now how many elements are there? Yes, I am writing here cardinality. And of B is equal to minus 1, 0, 1, 3, 4. How many elements are there? Again, 6 elements are there. Now, moving to our next subdivision. Yes, C. Describe the following set in roster form. Set C. X is such that x is equal to 2n plus 1. X is equal to twice n plus 1. And n belongs to capital N. And n belongs to capital N. Capital N, it means that set of natural numbers. Set of natural numbers 1, 2, 3, 4, so on, that up to infinity. Up to infinity. Now look at it. If I consider first natural number, that is 1, then formula says that, yes, it is given in set betterment. Formula is what? X is equal to 2n plus 1. 2n plus 1. For n is equal to 1. Natural numbers are 1, 2, 3. So I can write taking values, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. X is what? X is equal to 2 into n. That is 2 into 1 plus 1. X is equal to what? 2 into 2 plus 1. X is equal to 2 into 3 plus 1. X is equal to 2 into 4 plus 1. It means that 2 into 1, 2 plus 1, that is 3. 2 into 2, 4 plus 1, that is 5. 2 into 3, 6 plus 1, that is 7. 2 into 4, 8 plus 1, that is 9. And so on. How many numbers are there? Infinite. Means the set is not finite. So C can be written as set of all element. Yes, 3, 5, 7, 9 and so on. It's our third example. So in this question we write the sets in set builder form. Given set is in roster form. Roster form means listing. All the elements are listed, and given form is set builder. That is what formula is given. Now, moving to our next question. Question second. Describe the following sets in set builder form. Set builder form. Set builder means what? Set builder means that is in formula method. That is in formula method. Now, first sub question is yes, curly bracket is here. Yes, this set is called as only one element is there. So this set is called as singleton set. First, in solution, I am writing, yes, give name to this set. So for that, I am writing let A is equal. Set A is equal to curly bracket 0. Look at here. Only number is what? 0. In formula method, we write in more than 1 to 2 formulas. We write that set in more than 1 to 2 formulas. First, look at here. We look at set of natural numbers. Set of natural number is 1, 2, 3, so on that. Set of natural number is 1, 2, 3, so on that. And set of whole numbers is what? Including 0. Natural numbers including 0. So here, whole number can be written as 0, 1, 2, 3, so on that. Okay. But look at here. 0 is given. 0 belongs to W. Yes? 0 is in whole number? Of course. But 0 does not belong to natural number. Is 0 is in natural number? Starting from 1. So 0 is not there in natural number. So I construct a formula for writing that set. This set in set builder method can be written as, or set builder form can be written as A is equal to set of first generalize that term by x, set of all x, always set of all x such that standing line is for such that set of all x such that x belongs to set of all x such that x belongs to whole number. X is what? A whole number. But x does not belong to natural number. Look at it. 0 is in whole number, but 0 does not belong to natural numbers. So writing 0 there. 1 is in whole number, but 1 is in also natural number. So don't write. So only what? We get an element 0. So I am writing that example in set builder method as A is equal to set of all x such that x belongs to W, x does not belong to natural number. Some students are writing such as A is equal to in set builder method set of all x such that x belongs to integer. X belongs to integer. 0 is an integer. Yes. Integer, set of integers is what? So on that -3, -2, -1, 0, 1, 2, 3. So on that. So 0 is an integer. So I can write x belongs to integer and x is lies in between. Yes, 0 is lies in between clearly minus 1 to plus 1. So I can write here x is lies in between minus 1 to plus 1. That is a can be written as a is equal to set of all x's that x belongs to 1, comma minus 1 less than x less than 1. In this way also you are right the given set. Next sub question is set 0 plus minus 1 plus minus 2 plus minus 3. Okay, we write the given set in set builder form. Look at here how we write that set in set builder means we have to write a formula. We have to write a formula. Look at here. Observe this set. First we write the name of that set. So I am writing here in solution let b is equal to curly bracket starting from 0 plus minus 1 plus minus 2 plus minus 3. So I am writing here such as minus 3 minus 2 minus 1 0 1 2 3. Yes, minus 3 minus 2 minus 1 0 1 2 3. Yes, I am writing that's it as minus 3 minus 2 minus 1 0 1 2 3. If you remember, all these are integers. All these are integers from minus 3 to plus 3, including minus 3 and plus 3. So I am writing that set. I am writing that set in set builder form. It is a set of all x's that x belongs to integer. X belongs to integer. Which type of numbers are there? So these are integers. And I am writing one condition here. Numbers between minus 3 and plus 3. So I am writing minus 3 to plus 3. X is lies in between minus 3 and plus 3. Minus 3 is included. So I am writing minus 3 less than or equal to x less than or equal to 3. 3 is also included. That's why I am writing that set as, yes, the name of that set is B. In set builder method, the set B can be written as set of all x such that x belongs to integers minus 3 less than or equal to x less than or equal to 3. Now, next, describe the set in set builder form. That set is given here. Look at here. That set is 1 upon 2, 2 upon 5, 3 upon 10, 4 upon 7, 5 upon 26, 6 upon 37, 7 upon 50, 1 upon 2, 2 upon 5, 3 upon 10, 4 upon 17, 5 upon 26, 6 upon 37 and 7 upon 50. First, we have write that set in set builder form, that is in formula method. First, give name to that set. I am writing the name of that set is C. Let C is equal to C is set of the elements 1 upon 2, 2 upon 5, 3 upon 10, 4 upon 17, 5 upon 26, 6 upon 37 and 7 upon 50. Okay. Now observe the elements. Observe the elements in set C. Look at it. First element is here, second element, third element, fourth element, fifth element, sixth element, seventh element. What is the common properties there? Yes, these elements are in the form of P upon Q. That is something upon something. Okay, so I am writing that divided set. In numerator, what is there? 1, 2, 3, 4, 5, 6, 7. In numerators, the terms are 1, 2, 3, 4, 5, 6, 7. Means what is there? These are, yes, natural numbers. So I am writing the formula. In numerator, I am writing n. But n is what? Up to 7. So condition on n is what? N is equal less than or equal to 7. Or we can write n is less than 8, strictly less than 8. And in denominator, the terms are 2, 5, 10, 17, 26, 37 and 50 is there. So I am seeing that 50 is there. 50, yes. And in numerator there is 7. 7 square is what? 49. And 49 plus 1 is what? 50. Tell me about that 37. 37 can be written as 6 square is what? 6 square is 36 plus 1 is there. Now in denominator there is 26. 26. 5 square is what? 25 plus 1. So here 1 upon 2 is there. In numerator there is 1. 2 can be written as 1 square plus 1. So I am writing that term as n square plus 1. So the set can be written as in set builder form as C is equal to set of all x. This step is necessary such that set of all x, it can be written as set of all x such that x belongs to what? Natural numbers. Or the property is what? X is equal to, property is what? N divided by n square plus 1. And what is that? N belongs to natural number. N belongs to natural number and which are less than or equal to 7. Which are less than or equal to 7. So C can be written as in set builder method, set of all x such that x is equal to n divided by n square plus 1. N divided by n square plus 1 such that n belongs to natural numbers. So these natural numbers are less than 7. So I am writing n is less than or equal to 7. So I am writing n is less than or equal to 7. Now moving to our next solution. Zero. Describe the set in set builder form. 0 set of elements 0 minus 1 2 minus 3 minus plus 4 minus 5 plus 6 minus 7 and so on and so on. Yes, clearly it is an infinite set. Clearly the given set is infinite set. First, give name to that set. Since our this fourth example, so I am writing D is equal to set element 0 minus 1 minus 3 4 minus 5 6 minus 7 and so on. Now if we see, yes, the numbers are 0 minus 1 2 minus 3 4 minus 5 6 minus 7. I think these numbers are in whole numbers 0 1 2 3 4 5. These are in whole numbers. So I am writing this set as in set builder method. Yes, this set can be written as set of all x such that x belongs to W. X belongs to W. That condition I am writing here. And what is the main condition? X is equal to what? X is, yes, first term is 0, second term is negative, third term is positive, fourth term is negative, fifth term is positive. For that, look at here. minus 1 raised to n. Minus 1 raised to n gives 2 answers. It's plus 1 or it gives minus 1. It gives plus 1 or minus 1. Plus 1 when m. This n is even and minus 1 when n is odd. Remember about this. Minus 1 raised to n gives two values. It's plus 1 and minus 1. When it gives plus 1, when values of n is even, that is 2, 4, 6, minus 1 square is plus 1. Minus 1 raised to 4 is plus 1. Minus 1 raised to 6 is plus 1. When n is even, the values are positive. Minus 1 raised to 2, it's minus 1. Minus 1 raised to 3, minus 1. Minus 1 raised to 5, minus 1. When n is odd, then it gives value minus 1. So I am writing set D as in set graded form, set of all x such that x is equal to minus 1 raised to. In this set, we have the terms alternate plus minus plus minus plus minus. For that I am using minus 1 raised to n into n. Okay, and x belongs, I am writing n belongs to w, not x belongs to w. N belongs to w. If we take first whole number, that is 0, it's minus 1 raised to 0 into 0. It becomes 0. We take the second whole number, then minus 1 raised to 1. Second whole number is 1 into what? 1 is equal to minus 1 into 1, which is equal to minus 1. If we take third whole number, that is 2. Now I am writing minus 1 raised to 2 into 2. Square of negative number is positive. So plus 1 into 2, which is equal to 2, and so on. Means we write that set in the form of set builder as set of all x such that x is equal to minus 1 raised to n into n, such where n belongs to whole numbers. But students, in all the cases we are writing set of all, we are writing for set of natural numbers. For that, I am writing here in another form, alternative method. D can be written as D is set of all x such that x is equal to, this can be written as minus 1 raised to n minus 1. Minus 1 raised to n minus 1 into n minus 1 into n minus 1, and n belongs to capital N. Only for natural numbers we write this as the set of all x such that x is equal to minus 1 raised to n minus 1 into n minus 1. Look at here, take first natural number, that is 1. 1 minus 1 is 0, minus 1 raised to 0 is, yes, 1. 1 into 1 minus 1, 0. That term is 0. If we take second natural number, that is 2. 2 minus 1 is 1, minus 1 raised to 1, 1 is odd number, so minus 1, and 2 minus 1 is 1. So clearly we write this formula for representing the given set in set builder form. Now, students, the third question is here. If A is equal to, A is set given as 1, 2, 3, then find P of A, that is power set of A. Then find P of A. What is meant by P of A? That is, P of A is nothing but power sets or power set of given set A. In previous video, we learned about A is any set, then its power set is denoted by P of A, and P of A is defined as it is a set of all subsets of a given set A. The definition of power set of A: P of A is nothing but power set of A. If A is any set, then P of A is nothing but power set of A, and it is a set of all subsets of a set. Okay, given set. And there is one remark is given: if number of elements in A are n, then number of elements in power set of A, which is equal to 2 raised to n. So how many elements are in A? There are 3 elements. There are 3 elements in A. That is, cardinality of A is 3. Now, how many elements are in P of A? Therefore, number of elements in P of A is equal to 2 raised to 3. That is, how many elements are there? 8. So, tell me, subsets of A. Clearly, power set is nothing but set of all subsets. Set of all subsets. Tell me subsets of given set A. I am writing here. Clearly, an empty set is subset of all sets. So, I am writing only empty bracket. 1 is subset. Yes, this set is subset of that set. Of course, all the elements of that set are elements. So clearly, this is a subset. Yes, 2 is also subset. 3 is also subset of that set. 1, 2. The set 1, 2 is also subset. 2, 3 is also subset. And 1, 3 is also subset of that set. And itself also subset of given set. The set itself also subset of given set. How many sets are written here? 1, 2, 3, 4, 5, 6, 7, 8. Means we write all the subsets of the given set A. So I am writing in solution given A is equal to A is what? Set of 1, 2, 3. Here n of A, that is cardinality of A is 3. Therefore, P of n of A, cardinality of power set, or n of P of A, cardinality of power set of A, is equal to 2 raised to 3. That is 8. Now I am writing all the elements in power set of A. Power set of A is denoted by P of A. We have P of A is equal to, I am writing all these sets in a set. Subset of, it is a set of all subsets. So all subsets are here. So these all subsets are written in a curly bracket. So here is a curly bracket 1. I am writing first empty set. Empty set is here. So what? Only curly bracket is written here. Separate by commas. Each subset by commas. First one is 1. Yes, 2 is there. This is also subset. 3 is also subset. Nah? This 1, 2 is also subset. Next, yes. 1, 3 is also subset. 2, 3 is also subset. And finally, 1, 2, 3 is also subset. And I am completing that outer curly which is nothing but power set of a given set A. So students, in this video we learn some examples from exercise. I hope you understood today's examples. Thank you for watching the video.